Hello guys, welcome back to our channel. Today we are going to see about what is a serial in serial out shift register, how it works and how to make the Verilog code for this serial in serial out shift register. For this serial in serial out shift register, the concept is that here we will give the input as a serial manner, that is if we have a bits like 1011, here 1 and continued by 1 and 0 and 1, here the bits will be given by bit, and here it will be propagated through the flip-flops. Here I consider the D flip-flop and the output will be taken as serial output. That means here also the bits will be come by bit. Okay, we will see how it will be worked according with the truth table and also clock diagram. Here you can observe that here I am considering the D flip-flop. D flip-flop is nothing but a data storage flip-flop which can hold the data for a while of time. Here we can also see the truth table for this D flip-flop. Here clock and D and Q. Okay, Q is nothing but the output. Clock, if clock is 0, here the D is anything. Here it may be 1 or 0. Here I am representing it with the X. It will be stored the previous one, Q, and that means the previous state. Okay, or you can also say it as a memory. If clock is 1, if the D is 1, then the output will be 1. If clock is 1 and the D is 0, the clock output will also 0. That means when the clock is 0, wherever the output, that means here the D will be 1 or 0, the output will be the memory state. If the clock is high, then whatever the input of the D1, it will be come onto the output. Okay, in this way the D flip-flop will be work. Here I am considering the positive edge trigger D flip-flop. That means when the positive edge is received, then only the D flip-flop will be respond, otherwise it will be not respond until and unless it will get the next positive edge. Okay, here I will consider the 4 flip-flops, so it will take a 4 clock cycles to reach the output state from the input. Okay, that means here I am considering the clock. Here I will consider Q3, or you can say Q3, Q2, Q1 and the Q0. Here are nothing but the Q3, Q2, Q1 and the Q0. Okay, initially I am considering all these outputs are 0 and I will set the input as a here 1 0 1 0. Okay, now first the 0 bit will be fed to the D flip-flop. Now when the clock signal is high, the Q3 will be 0 and remaining R will be in their previous states. Now next the 1 will be fed to the D flip-flop. Now initially here 0 is present, right? It will be shift to the Q2 position and 1 will be come at the Q3 position. Now Q, and it will be shifted to the next position and 0 and the 0. And next for the high clock cycle, that means the positive edge, next the 0 will be come to the Q3, this one will be come to the Q2 and here the 0 will be moved to the Q1. So 0 1 and next 0 and next 0. Okay, and finally another one, here another one will be there, it will be now come to the Q3. So 1, here 0, here 1, here 0. In this way the inputs are fed by the single bit and the output will also taken as a bit by bit. Now we will see the clock cycle. Like I am considering few clock cycles. Here you can see that I am considering some few clock cycles. Now initially all the bits are okay, all the bits are initially 0. Yes, here initially the Q3 is 0, right? So for the next clock cycle until it will continue 0 and remaining our next continuous states. Okay, now next the Q3 will be 1, right? So it will be 1 and continue until the next state. Here remaining, here the Q2 will be 0 and the Q1 will be continue to the next state and Q0 will be continue to the next state. Here next the Q3 is 0, Q2 is 1 and the Q1 is 0, right? So here Q3 will be again come to the 0 0 and q2 will be 1 and q1 will be 0 and q0 will be previous state. Now the state is over, right? This clock cycle, this one is over, this one is over, this one is over, and finally this state. Now the q3 is 1 and continue to the next state. q2 is 0, so it will be 0. q1 is 1, so half, and finally q0 is 0. Here you can observe that we can observe that 1 0 1 0. Yeah, you can see that here 1 0 1 0. Here what with the input is we given 1 0 1 0 and we are getting the output as a 1 0 1 0. Here you can observe that the signal is only responding for the positive edge cycles because we taken as a positive edge. So in this way the serial in serial out shift register will be work. Now we will see how to make the Verilog code for the serial in serial out shift register. Okay guys, now we will start the making of Verilog code. So for that I am creating the module SISO. Here we will require some inputs, right? Input SI, and SI is nothing but the serial input, and the clock and reset. And the output I will consider it as a register, output register S not, because it will store the previous value and so that it will changes according with that. And I will take some temporary register 3 is to 0. 3 to 0 means here we are considering the 4 flip-flops, right? So here there will be a 4 intermediate outputs, so those output will be stored in this temporary register. Okay, a temporary register, and I will use it as consider as a register temp. Okay, now I will use always at the rate block, always at the rate posage clock begin. If reset equal to 1, that means if the reset is high, then what we have to do, all these outputs present in the right. So I will make the temporary register will be 0, that means 4 bit 0 because there are 4 bits, right? So 4 bit 0. And now if reset is not equal to 1, then what we have to do, and first I will finish this, else begin. Else begin, what we have to do, first initially the temp will be, sorry, here casting as a temp. Here the temp will be right shift for one time because we are considering a left to right, right? So I am considering the right shift operation. If you consider the left to right, then you will consider the left shift operation. Based on the word design, you can choose any shifting operation to meet your requirements. Okay, here I am considering as a right shift operation, so I am using the right shift operator, so that the variable will be right shift once, then it will take the output like as a, here I will, for temp initially the temp will be SI, here it will be taken into the third bit. Okay, now for S naught the temp will be the final output. The final output is nothing but the 0, right? So temp 0, and I am closing this and end module. Here you can observe that here I am designing a refining my inputs. These are nothing but the input, clock signal, and the reset signal. And output I will take some register called S0. Here there are a few intermediate outputs are there. So for that to store those intermediate outputs, I taken as a temporary register. Here I will consider as a positive clock because I am considering when only when the signal response, only when the positive signal is received, then only the input signal will be respond. So the outputs will be taken. So now we will write the test bench. I am writing the module tb. Here the inputs what we taken is SI, clock, and the reset, and outputs are nothing but the wire S0. Okay, here I will extract the inputs from the design SSSO1, SI, reset, clock, and the S0. Okay, now I will start writing the test bench initial begin. Here initially I will clock, assuming the clock is equal to 1. Now I will write the dump file command so that we will see those outputs in the waveform file.bcd and the dump fats 1. Okay. Now here I am using the forever command. That means until and unless we are giving the input, the clock signal will be randomly changed for every 5 seconds. So the clock is equal to complement clock. Okay. Now I am closing this. Now I am again giving the test means. Now we will give the serial inputs. Initially I will consider reset is equal to 1. So here whether the output is any, I will give S1, and now I will give here some time delay. I will give the like as a 10. Now I am considering the reset is equal to 0. Now I will give the inputs as S. Initial I will give the initial output as a 1 and some time delay call 5. Now I will give the 10 so that it will complete all the clock cycle. I mean positive and the negative clock cycle. Here I will give 0, 1 0 1 0, right? Here I given the 1 0 1 0. And now I am finishing this test bench and closing this and end module. So this is the test bench required for to design our SIS4, that is nothing but the serial in serial out shift register. I am saving this file. Before that I will select the tools and the simulators. I will save this file and I will run this. Now I will give the some name called SIS4, which is nothing but the serial in serial out serial out. Now I am saving this file. Now I will run this. As here there are some errors. So here we are facing some errors like here first error in the design.sv.9. Here we have not properly mentioned in the there is a syntax error. Here there will be temp after the declaration. So I am removing the front side. And there is some syntax error in the test bench 10 and 11. Here you can observe that. Here I will consider the dollar and this is the dollar. Now I am saving this file and I'm going to run this file. Yeah, here the output waveform is obtained. Here you can see that initially the reset is high there and there is a no previous inputs are there. So there is a nothing in the S0, and after some time here we are giving the S as a 1 0 1 0, and here the starting as a 1. Here there will be a 4 clock cycles time delay for to receive the output because it has to cross the 4 outputs, right? Here I will add some dummy sequences like here you can observe that. Yeah, right. Now I'm saving this file and I will run this. Here you can observe. Yes, here you can observe. Initially we given 1010, right? Here in this 1010. In this way, after the 4 clock cycle, the output will be append in the bit by bit wise. So in this way, the serial in serial out shift register will be work. If you have any doubts, please mention in the comment section. You can get this code in the GitHub through the link provided in the description. Thank you. Thank you for watching this video. Stay tuned for the next video.